All right, AP Calc. Here we're going to go over some examples of taking the limit algebraically, specifically looking at the complex fractions and the trig and a couple piecewise at the end. So let's get started. Number 11. Here we have a complex fraction. We're taking the limit as x goes to 0 of 1 over 6x, 6 plus x minus 1/6 all over x. And the way I do this is to find the LCD. So notice that we got these little fractions here with a denominator of x plus 6 or 6 plus x and 6, and they share no common factor. So the LCD is simply just multiply those together. And I'm going to multiply it by everything on top and this one as well. Again, x plus 6 and 6 plus x, those are the same thing. Notice here I have a minus sign, so let me just write that as adding the opposite. And then I have to multiply on the bottom as well. Okay, we are taking the limit as x goes to 0, so make sure you're showing the correct notation. And simplify the top. Now this one, the x plus 6 would cancel out, so I'm left with 6 times 1 is 6. Here, the 6's would cancel out. Notice I have that negative from here. I think of that as a negative 1, and we need to make sure we distribute. So we're going to have negative 1 times x is negative x, and negative 1 times 6 would be negative 6. On the bottom, we have x and a 6, and x plus 6 all multiplied together. So far, so good. The next thing we need to do, do not try to cancel out anything yet until we simplify the top. So we have the limit as x goes to 0. 6 minus 6 would cancel. We're left with a negative x. We have 6 times x, x plus 6. At this point, we can cancel out a factor of x on the top and the bottom. Even though this is a negative x, it would leave us with a negative 1 on top. And again, the x's would cancel out. So we have the limit as x goes to 0 of negative 1 over 6 and x plus 6. At that point, since we just canceled, we're able to put 0 in there. So we would have negative 1 over 6 times 6 is 36. So we get negative 1 over 36. Number 12. Again, we have a complex fraction. The LCD here would be 5 times x minus 5. And I'm going to multiply this by 5 times x minus 5. And on the bottom, 5x minus 5. And the x minus 5s would cancel out. We have the limit as x goes to 0. 5 times 1 is 5. And here we have a plus sign. 5s would cancel out. And we just have x minus 5 there. On the bottom, we have 5 times x minus 5. On top, we can combine like terms. So those would cancel out. We would have that x left over. And should be able to see right away that you'd be able to cancel that x with the x on the bottom. So we have the limit of 1 on top over 5 times x minus 5. Skipping a little step there. And that would leave us with negative 1 over 25 for our final answer. Okay, now we get to the trig ones. So all of these are going to use some trig identity. So the most common ones are going to be the Pythagorean identities, such as sine squared plus cosine squared is equal to 1, or these double angles. I think all of them on this page involve sine and cosine. So those are the only ones that we should need. This first one, cosine theta, there's nothing to do there. And if we look at the top, we have 1 minus sine squared. If we look at our formula sheet here, it doesn't seem to match up with any of these, but this one we can change a little bit. So off to the side here, if we solve this for and get the sine squared, we can move that to the other side. We'd have cosine squared theta is equal to 1 minus sine squared theta. And that's exactly what we have on the top here. So we can rewrite this as the limit as theta goes to pi over 2. I should note that you should check to make sure that you can't do this, that you do get an indeterminate form. So on top we have cosine squared theta. On the bottom we have a cosine theta. Cosine squared theta means it's cosine times cosine. So 1 will cancel out with one of these. We still have 1 cosine theta left over. And now we can take the limit. So what is cosine of pi over 2? That would come out to 0. Number 14. This one you have to use two identities. So this cosine squared minus 1. Again, we're going to use our trig identity. So it looks close to here. If we just go a little bit further, take cosine squared theta, subtract 1. That would come out to negative sine squared theta. So on the top, we can change it so that it says negative sine squared theta. And on the bottom, sine 2 theta, we have an identity for that as well. So that is 2 sine theta cosine theta. And now one of the signs will cancel out. So we have the limit of negative sine theta over 2 cosine theta. And we can put pi in there. And if we go over to pi, that's going to be on this part of the unit circle. Sine of that is going to be 0. Cosine of that would be negative 2. Of course, it doesn't matter because 0 divided by anything is still 0. Number 15. Theta is going to negative pi over 4 of 1 plus square root of 2 sine theta over cosine 2 theta. So the top might seem a little bit confusing, but let's look at the bottom. We have cosine 2 theta. Here again is my little cheat sheet. And if I look at cosine 2 theta, I've got 3 different choices. Choice 1, choice 2, choice 3. Which of these is going to help us here? Well, if you look at the top, you have a 1 and you have a sine theta. There's no cosine theta. So we want to try to use this guy, 1 minus 2 sine squared, because that's the closest match to what we have on top. Again, with indeterminate forms, we're always trying to do some algebra or trig manipulation so that we can eventually cancel things out. So on the bottom, we can write it as 1 minus 2 sine squared theta. Now, we can't cancel anything out yet because you can only cancel out common factors. And if there's a plus or minus sign here, that actually ties these all together as one factor. So nothing really to do on top. But on the bottom, you have a sine squared, you have a 1. This should remind you of a difference of squares. The difference of squares is a squared minus b squared, which just factors into a plus b, a minus b. And so if we keep that in mind, we should be able to factor the bottom to something useful. So I'll put my parentheses out here, try to make enough room. And this is a square. Sine squared is a square. 2, not quite a square, but we'll work with it. So 1 times 1 would give us 1. A difference of squares means one has to have a plus sign and one has to have a minus sign for our factors. And we definitely need to have a sine theta here at the end. And then what number times itself would give us 2? So that's going to be square root of 2. And you can check by foiling that that does indeed work. And now we can cancel the 1 plus square root of 2 sine theta. So that leaves us with the limit as theta goes to negative pi over 4 of 1 over 1 minus square root of 2 sine theta. At that point, you can put negative pi over 4 in there. And if you work that out, you should get 1/2 for your final answer after a little bit of arithmetic there in trig. Number 16. 16 actually had a typo because I think the original problem that I had put had negative pi over 4, which actually doesn't require any substitution. You can just plug it in. I mean, it doesn't require any trig identity, so you can just plug in the negative pi over 4 and do direct substitution. So this is what I think I had intended, is theta it goes to pi over 4. Because then on top you would have 0 and on the bottom you would have 0. You get the indeterminate form. So if you did it the other way, that's fine. You get an answer of 0. But if we do it this way, which is the way I'm going to work it out, the way I had intended, then we'll get a different answer. So cosine of 2 theta we have on top. Again, we have, here's my little cheat sheet, cosine of 2 theta, which one's going to be the closest match so that we can cancel. If we look at the bottom, we have a cosine and we have a sine. So the one that has both of them is going to be this guy, cosine squared theta minus sine squared theta. So we want to put that on top. This is on the bottom. And just like the last one, you may not be used to this, but cosine squared minus sine squared, we can actually factor that. Again, it is a difference of squares. Do not try to cancel out right away, because again, we have minus signs here, which are going to tie these all together. We can only cancel out common factors. So again, we need to factor the top into cosine theta plus sine theta and cosine theta minus sine theta. Running out of room there. Sorry, that looks messy. So the cosine theta minus sine theta would cancel out, and we would have the limit as theta goes to pi over 4 of cosine theta plus sine theta. Now you should be able to plug in cosine of pi over 4 plus sine of pi over 4 gives square root of 2 over 2 plus another square root of 2 over 2. This is like having a half and a half, which would add up to a whole. So we just end up with a whole square root of 2. And again, that was the intended answer if the limit was going to pi over 4, but if you did it with the negative pi over 4, you would get 0. And you could also do it the same way. Okay, 17, this is probably the easiest one. So the limit as theta goes to pi over 2. On top we have sine of 2 theta, and from our cheat sheet there's only one identity that uses sine 2 theta, and that's 2 sine theta cosine theta. So there's really no choice or decision to make. We need to rewrite. And then on the bottom we have cosine theta. This means 2 times sine times cosine. The cosine thetas would cancel out, and we are left with the limit as theta goes to pi over 2 of 2 sine theta. At that point, we should be able to plug in sine of pi over 2 is, it's going to be 1. 2 times 1 is 2. So that comes out to 2. 18 is very similar. You're going to do this kind of same thing, except the signs would come out. And for 18, I'm not going to work out the whole thing, but you should get 1/2. Okay, 19 and 20. These are piecewise functions. So what this is saying is we want to take the limit as x goes to -3 of this function. Here's the function. It's defined as a piecewise function. Most of the time it's going to look like this guy, x squared plus 2x plus 1. Except when x is -3. When x is -3, it's going to be defined at 3. Now think about what this looks like, x squared plus 2x plus 1. Just recognize that that's a quadratic. And you think a little bit further, we could factor it into x plus 1 squared, which means it's going to be a parabola that has this vertex here at -1. And kind of looks like this, except at -3, it's going to have an open circle because it's not defined at -3. If it were defined at -3, we could just simply plug it in here, or you can use your calculator. -3 squared is 9 minus 6 plus 1 would be the point -3, 4. So that point is an open circle. It's been taken out, it's been removed. And at that x value at -3, the function is defined down here. at negative 3, 3. But when we take the limit, remember what that means. When we take the limit, we're approaching from the left side, or we approach from the right side. We're getting closer and closer to that open circle. So when we take the limit, as x goes to negative 3 of f of x, we're approaching the open circle, and the limit would be 4. Now, I didn't ask this, but if I were to evaluate the function at negative 3, then the answer would be 3. But that's different. So this function is not continuous. It has a removable discontinuity at that x value. And 20 is similar. So 20 says, find the limit as x goes to 1 of this function. This function is going to look like a line, 2x plus 1. Again, for both of these, you don't necessarily have to graph it. All you have to realize is it's a single point that's taken out when we're taking the limit as x goes to that value. So this is really irrelevant. And over here, this part is really irrelevant because we are approaching an open circle. We're approaching that removable discontinuity. And that means we can just use this definition of our function to find the limit. I don't really have to graph it or anything. I can just put 1 into there. So if I'm taking the limit here, if I put 1 in of f of x, the limit should come out to 3. And hopefully that helps. If you have any other questions, just let me know. We'll see you. Bye.